Good day, viewers. In this virtual class, we are going to look at the uh, derivative or differentiation of exponential function. Okay, if we have a function y is equal to e raised to power x, or we have a y is equal to e raised to power f of x, or if we have a y is equal to a raised to power x. So we're going to take our time off here, to find an appropriate way of finding the derivative of this kind of function. Okay, here in this first function here, if we have y is equal to e raised to power x, here if we look at the power series associated with this number is 1 plus x plus s squared over 2 factorial plus s cubed over 3 factorial plus x raised to power 4 over 4 factorial plus x raised to power 5 over 5 factorial, till infinity. Okay, now we want to find the first derivative, which is the y dx of e raised to power x here. And if we do that, this, if we differentiate this, is a constant, will give us 0. If we differentiate x, it will give us 1. If we differentiate s squared over 2 factorial, it will give us 2x over 2 factorial. Plus, if we differentiate s cubed over 3 factorial, it will give us 3s squared over 3 factorial. Plus, if we differentiate s raised to power 4 over 4 factorial, that will give us 4s cubed over 4 factorial. If we differentiate s raised to power 5 over 5 factorial, that will give us 5s raised to power 4 over 5 factorial. It will continue like that till infinity. And if we observe here, we see that here this becomes 1 plus. Look at 2 over 2 factorial. It's 1. 2 factorial is 2. So here we'll be left with x plus 3 over 3 factorial. Simply means 3, to expand this factorial, 3 factorial, it means 3 times 3 minus 1, that means 3 times 2. So we can stop, we can say 3 times 2 factorial. So here, this expression here becomes s squared over 2 factorial plus, similarly, 4 over 4 factorial is the same thing as 1 over 3 factorial. Okay? Here becomes s cubed over 3 factorial. Similarly, this will become x raised to power 4 over 4 factorial till infinity. And what we've just noticed that this same derivative of this is the same thing as this function y. So what in effect, if we are saying y prime is the same thing as e raised to power what? X. So if given a function and exponential function e raised to power x here, it simply means that if the function here, the power here is just x or just one function, it's going to give us that same. If we differentiate it 100 times, it's still going to give us 6. But something might definitely happen if the power here is not just only one number or only one function. Here we'll have to derive a formula for that. Okay, now let's have assuming we have what we have here, y is equal to e raised to power f of x. Then how do we now find the derivative for this number? Okay, for this function, right? Here what we do, we're going to use what we call function of a function. Function of a function to find the derivative of this. First, if we assume that we say let this function f of x here be u, we say let f of x, or let u is equals to f of x is equals to f of x, then this function here y will become e raised to power u. Okay, but since we're expressing this one u as f of x, then we can see our dy, the x is equals to the y, the u times the u over the x, or the y, the s is equals to the u, the s times the y, the u. Now let's find our dy du. So remember, if we are saying dy du, this one, if we differentiate this compared to what we have just said here, that if we find the derivative of this, it's still going to give us this one. So dy du here is going to give us e raised to power u. Then let's find the u ds. The u ds will just give us f prime, that is the first derivative of what? F of x. So whatever this function is, when you differentiate it one time, is your du or ds. Then let's aggregate our term here. Our term here is dy dx, which is now y prime is equals to dy du, which is e raised to power u, times our du, the s is f prime of x, f prime of what? X. So if we substitute, we know that u is equals to f of x. So here we have e raised to power f of x times f prime of x. So we can rewrite this as f prime of x e raised to power f of x. So this is the derivative of if this function here is not just a single, it's not just only one variable, but if the variable, if this one is given another function different from just x, the formula will be f prime of x e raised to power f of x. Okay, now that is for that. Then we're going to look at this. Given this type of function, given this kind of function, how do we necessarily establish the formula for this? Okay, let's look at this. We have here that y is equals to e raised to power x. Then how do we find the derivative of a function of this nature? We have to do some transformation here. Here, first of all, we take ln, the natural logarithm of both sides. That means ln y is equals to ln e raised to power x. And applying the appropriate laws of logarithm here, that means x will move this way, so that we have ln y is equals to x ln a. But we are looking for y. Now let's make y subject to the formula. Here, from the law of logarithm, natural logarithm here, this our y will become this ln here moving to this way will become exponent, the natural logarithm, e raised to power x ln a. So it's going to carry this one with this form of power. Okay, then we have obtained y. Now we have transformed y. We have done some transformation. So that means this function is now differentiable. We cannot differentiate it. Then applying what we have just done here now, given this, for us to obtain the value of y, the y dx, we can say that let u is equals to x ln a, so that our y is equals to e raised to the power u. Then to differentiate this, our du dx. So here this is a product, we apply product to here. Alright, here we differentiate x. To differentiate x will give us 1 times ln a, that will give us ln a. Plus, if we differentiate ln a is a constant. The constant here, if we differentiate the constant is 0. 0 times s, that will just give us 0. So here, this will just be ln a. Then if we now differentiate, this is the y all over the u, this one will also give us just e raised to the power u. Then the next step is we look for, we aggregate this term that our dy dx here will become ln a, which is du ds times this, then e raised to the power u, and our u is x ln a. Okay, and it will not end there. If you recall the whole of this, if you recall, e raised to the power x ln a is equals to y, isn't it? Is equals to y, and y is what? Is also what? A raised to the power x. So our dy dx is equals to ln a open bracket a raised to the power x. So dy ds of this function, dy ds, the first derivative of this function, is equals to you take the ln of this, then a, that the constant number there, raised to the power x. That is how to find the derivative of y is equals to e raised to the power s, y is equals to e raised to the power f of s, and y is equals to a raised to the power x. So I hope this explanation is very clear, and we're still going to continue by giving more example on this. Here we're just trying to establish the formulas. Alright, please, all you help me do, help me subscribe and also share. Or you can also hit the notification button. Once some of this video come up, you'll be able to have access to them. Have a nice time.